This is the Unit 3 test review on linear functions. Number 1 says find the domain and range of function h. So here's function h. And since this is a discrete graph, we are going to write out all of our x values for our domain. So we start with our lowest, -7, then -3, and -1. Then we have a point at 1 and also a point at 4. So those are our x values. Then for our range, we're going to write out our y values. We have 2 dots here at -2. We only need to write that once. Then we have 3, 6, and 7. I'm going to do the same thing over here for b. This is function f. So my domain, again, I'm looking at x values. So -6, 0, 2, 4, 7. And for my range, I'm looking at my y values. So I'm going from the bottom to the top. Lowest y value is -4. Then I have -3. I have 2 of them there, but I'm only going to write it once. And then 1 and 5. So number 2 is different because these are continuous. So for domain, I'm going to use inequalities. So I am looking at how low does it go, how high does it go. So my graph is going to start at -7 and end at +7. But we can see that -7 has a closed circle and +7 has an open circle. So I'm going to show that by using my inequality symbols of closed circle and open circle. Now for range, I'm looking how low does it go and how high does it go. So the lowest y value that I have is -3, and it's closed on this side, open on this side. So we're going to go with closed. And the highest that it goes is 4. Okay, over here, again, least to greatest. So I have -2 as my boundary on the left, and +8 as my boundary on the right. Both closed circles. And then my lowest point is -1, and my highest point is 5.
Found it. Exponential.
Okay. We are still finding domain and range here. We just have a word problem. A concert venue holds 50 people. Each ticket costs $15, and a function can be written that describes the total income of the venue as a function of the number of tickets sold. So our tickets sold are going to be our x, our independent variable. So we can sell none. Maybe nobody comes. We can sell 1 ticket, 2 tickets, 3 tickets, 4 tickets, all the way up to selling 50 tickets. Now my range, it said that it's the income of the venue. So each ticket costs $15. Well, we all know that if nobody buys any tickets, we're not going to make any money. Then if 1 person, that would be $15. 2 people buy, that's $30. And then if 50 people buy, 50 times 15 would be $750. Again, this is discrete because we aren't going to have fractions of people, and our range values, our only options are multiples of 15. Okay, over here, swim team has 15 people on it. Bags of chips cost 45 cents. A function can be written that describes the total cost of chips as a function of the number of bags sold. Find the domain and range again. So number of bags sold, again, is going to be our x. So our domain, we could, of course, not buy any chips. You could buy 1 chip, 2 bags of chips, 3 bags of chips, all the way up to 15 bags of chips because we have 15 people. And then the cost of the chips, if we don't buy anything, we don't spend any money, then we have 45 cents, we have 90 cents, all the way up to if we bought 15 bags of chips at 45 cents each, that would be $6.75. Determine whether the scenario is discrete or continuous. Students are selling containers of cookie dough as a fundraiser. For each container sold, they make $1.75 profit. The club purchased a case of 48 containers of cookie dough to sell. So we have to think about what's X and what's Y. So they're selling containers of cookie dough. That's going to be our X. And then the price or their profit, how much money they're making, that's going to be the Y. So can we sell portions of cookie dough? No. We would sell 1 container, 2 containers, 3 containers, 4 containers. That would be discrete. Water is added to a pool and fills at a rate of 37 gallons per hour. It takes 900 gallons to fill the pool. So our X is going to be hours. Our Y is going to be gallons. So can we have portions of an hour? Absolutely. So this would be continuous. Circle which representations are functions. So for a function, there's a couple of things that we're looking at. We are looking at if we pass the vertical line test, if we're a graph. We're looking at if we have repetition. So let's look at our X's and Y's here in this table. All of our X's are distinct and all of our Y's are distinct. They're different. So we don't have any repetition. So we're going to go with yes on this one. Okay, B. We have -2 pointing to 2 on this mapping. And we also have +2 pointing to 2. That would not be a function. If we think about what that would look like on a graph, we would have -2, +2. And we have +2. Oh no, that's okay. It's not those ones. It's right here. The 0 pointing to -3 and this 0 pointing to -6. So 0, -3, and 0, -6. That's what causes the issue and not being a function. So the 0 being mapped to -3 and -6 is where we have the issue of not being a function. Okay, over here, 5B. Right here, right here, right here, right there. All those points, we are failing the vertical line test. So we're going to go, no, not a function there. And then here, we are totally fine. Vertical line test, we are passing every point on that graph. Okay, number 6. Find and interpret the x-intercept, y-intercept, and slope. So our x-intercept is going to be where we cross the x-axis. So I'm going to estimate that to be, that looks like it's 2.5. So maybe 2.3. And my y-intercept is where I cross the y-axis. And that looks like 1,000, 2,000, 3,000, 3,500. Okay, the interpretations will be in the next video.